In this video, we're going to talk quickly about the normal distribution. Normal distribution, very, very common. Things like mass, IQ, these are normally distributed. Height, all of those things normally distributed. Normal distribution is the bell-shaped curve. Most data is going to be concentrated in the center, and that's what gives it the bell-shaped curve. Now today we're going to talk about three things with this one. In this video, we're going to talk about the shape, the mean, and the standard deviation. Now the standard deviation is probably something that's a little bit new for some of you. Don't worry about what it is for now. Shape is classic bell shape. It's symmetric. The vertical line in the middle is the mean, and it's same on both sides. Most data again concentrated near the middle. The mean is just the average. That's always going to be in the middle. It's represented by the Greek letter mu, the funny looking long U. We're going to see that in formulas a little later on. Standard deviation. Now this is something that's probably new. It's a measure of spread, how spread out the data is from the center. We're going to use SD as an abbreviation for it most of the time, and you're going to see it represented in formulas by the Greek letter sigma, sort of a funny sideways looking 6. Here's three normal curves. All have the same mean. Notice they all vertically line up, but the spread's different, so they all have different standard deviations. The red curve has the smallest standard deviation. Most of the data is concentrated right towards the center. Blue is going to have the biggest standard deviation. Data is more spread out from the middle. In contrast, we can have curves like these. These curves all have the same standard deviation but different means. Same standard deviation because they all have the same shape. Different means because they all have different starting points for their means. Blue has the smallest mean, it's furthest left. Red, the biggest, furthest right. Now the normal curve and how it relates to probability, well, it's the area under the curve that's representing the probability. The total area under the curve is from negative infinity to infinity. The total area is going to be 1. And because it's symmetric, from the mean in either direction, you're going to have a total area of 0.5. That's something we're going to use to our advantage when we make some calculations with this. Now, this symmetry thing comes in again. If we go one standard deviation either side of the mean, we're going to have 68% of the data. So, for instance, a mean of 100 and a standard deviation of 15, we're going to have 68% of the data between 85 and 115. Notice the symmetry again. Same proportion on each side of the mean. If we step it up to 2 standard deviations, we're going to have 95% of the data within 2 standard deviations either side of the mean. Getting less because as we go further from the mean, we're gathering less area as we add up. Mean of 20, standard deviation of 4. That would mean between 12 and 28, we have 95% of our data. We can go a little further. If we step out to 3 standard deviations either side of the curve, we're going to have 99% of the data, 0.99. So, a mean of 300, standard deviation of 50, 99% of the data will be between 150 and 450. Notice again the symmetry, and again as we go further, we're gaining less area for each increment we move from the mean. That's our introduction to the normal distribution.